All right, welcome to class, students. This is Thursday, 2/11. Of course, now that means we're looking at lesson 2.2 today. So we've been working a lot. I mean, we've been doing a lot of great things, and I have to make a note here. I just noticed it that there's a discrepancy in your grade book, and I'll be fixing that today. Right after the class, I'll fix it. Um, I've Can you guys hear me now? All right, cool. I don't know what happened. Maybe something went goofy. All right, great. All right, so thank you. All right, so um, Melanie, have you ever used Quickly before for signing in? Because this is how I get everybody's attendance for today. All right, autofocus there. There we go. All right. So we're looking at lesson 2.2 called In and Outs. I mean, now I know this probably is more algebra based than anything else. Um, but don't get alarmed by it. I'm going to go over a couple things with you, and I'm going to talk about why we have this concept of equations, basically. Why do we have um, ins and outs? So basically, when we're looking at equations and such, let's just give one that, oh, by the way, let's give one that you guys already know about because we covered it actually, and that is this one. All right, I went over this one with you before, computing simple interest. That was a formula I gave you, and actually, I bounced to page 170 at one time to show you that. Along with that, you'll find on page 173 the formula for compounding, finding compound interest. But you already have those. I know, Melanie, you don't. Don't worry about it. I mean, you'll get it. Can you guys hear me now? All right, guys, I apologize for that. I just don't understand what's going on. Why? Hopefully it doesn't do that consistently. This is kind of disturbing me, so sorry. This doesn't normally happen. This is the first time I'm experiencing this. So you guys have to just deal with me. That's all. Just deal. All right, let's try this again. Let's keep on working. We're busy, but only way we can get working is if you guys can hear me because I talk a lot, because I like hearing myself talk, not. But anyway, was trying to talk to you guys about was the fact that the principal value, okay, that represents the p-value, and then you have the r represents the rate, and then the t represents the time period, okay. So the thing is like right here, if you wanted to go ahead and compute something, look at what they'll do to you. They'll give you the value of input, start at $2,000, so that would be the value of the p, all right, and then you have the 3%. You'd put that in for the rate, all right, and then you go ahead and put in the number of years is 1, so you put 1 for that for t. So the thing is, they'll give you those values, and you have to just be able to compute it, and that's called inputs. All right, that's what this is all about, is inputs and outputs. All right, these are variables that represent different things that you can let them represent, and they're called variables. All right, because they represent unknowns. Like you've known variables or equations before. Such would be y equals mx plus b. You've heard of these kinds of things before. It's not like this is new to you. All right, you've had that in algebra 1. All right, so you have constants, which are just numbers. All right, they're just numbers, and they can vary. Like a number 12 is a constant. All right, because no matter what, it's still the same value, right? Because it doesn't change. It's just one thing, one value. But I mean, you have a magnitude of constants, right? Infinite amount of numbers can represent a constant. All right, so when we're looking at this, we have what's called independent and dependent variables, which we're going to have a discussion in Alex about. All right, this is a really good discussion. Here I say the age of a tree. Now, age, or I should say more or less time, is our independent variable at all times. No matter how you spin it, all right, the variable of independence is going to be something that can't be really controlled, or that is forcing something else to be predicted or occur. And such would be time. Time, like, ages things. So, but the age of something is dependent on the amount of time that went by, right? So here's it says the age of the tree and the height of the tree. Well, the age is the time that went by. So the age of the tree is because time had passed, which is uncontrolled. So it's independent. But then you're talking about the height of the tree. The height of the tree is growing every single year. Now, of course, it really doesn't grow that much when it meets its peak, right? So thing is that the independent, though, would be the age, and the dependent would be the height. Here's another example: the number of practice sessions. Now, the number of practice sessions would definitely make for the independent variable, because the quality of the music performance is dependent on the number of practice sessions, and that's why I have this little arrow there. All right, it's very faint; you can't barely see it. But now you score your score on a placement test and the math scores you've taken previously. Well, the math courses you've taken will definitely dictate how you place on it. How you do on a placement test. So what you're doing is asking yourself, what is the dependent variable versus the independent variable? What is depending on something else? That is the cause of what we're trying to do. All right, here's the idea that we're looking at. And I'll give you a couple more examples through Alex, which is what you use for your system. But then you're looking at input and output. And of course, these are different equations that you look at, all right, that dictate that. Now you evaluate once you go ahead and compute it. Now, you just looked at this one, kind of a formula, right? And equations deal with having equality or equal signs, where expressions do not. They just have simple variables and constants and such. So there's a magnitude of different things that we're looking at here, and I don't want to overwhelm you with all this. This is not the point of any of this, me covering this. It's just giving you an idea about how you have this independent, dependent variables, you have constants, you have variables, and you have inputs and outputs. Let's take a look now at the Alex, and let's see if we can do a couple of those problems. And I think you could find it. You can do this. Let's go ahead and open up that. All right, now we're gonna, of course, these are not available to you. I'm just going over the stagnant homework, I called it, static, but yeah, this is a pretty big, big problem. Not like what we had on Tuesday. Tuesday was rather easy, right? Mean, median, mode. That was pretty simple, straightforward. All right, let's take a look at this now. Now, you're going to have questions similar to this, right? So it says we're looking for what is the independent dependent variable. Now, I kind of gave you a little bit of a taste of that when I showed you the book. Now, it says the amount of certain medication taken in the morning influences the amount of sleep that you get at night. What is the dependent variable? And what would you guys think? I mean, give me an answer. What do you think? What would be the dependent variable? Remember, keep on asking yourself the question. The dependent variable is what's going to be influenced by something else. So which one do you think it's going to be? No answer? You guys, okay, sleep. Now, Maria's saying sleep. Okay, let's see if that's right. Now, the amount of certain medication taken in the morning influences the amount of sleep at night. So now medication is influencing sleep. So yes, sleep would be the amount of sleep would be the dependent variable because it's the amount of medication taken. Okay, so great job, Maria and Melanie. All right, now let's see if you guys can get this next one. Omar works at Adventure Fun Park. He notices that the daily number of tickets sold at the park varies with the daily high temperature. What is the independent variable in this relationship? So I'm being patient, just wait for you guys to answer. This is a good way of seeing whether or not people are paying attention, right? I mean, there's no reason to be scared if you get it wrong. I mean, it's not like you're going to get crucified, but just pick one. Which one do you think's the independent variable? And what you're doing is you're saying, well, what is it that's going to then be the thing that impacts something else? Now, the number of tickets sold is going to be dependent on the temperature, right? Because if the high temperature is really, really high, right, then the number of tickets probably not going to be, you're not going to sell a lot of tickets. So then he notices that the daily number of tickets is sold varies with the temperature. So that varies, meaning that it's dependent on the high temperature. So the independent variable here is actually the temperature, and Melanie, a good way of looking at that is, can you control temperature? And see, you can't, right? So it would be definitely independent, because there's no way you can control the temperature, just like you can't control time. So the independent variable would be the temperature, the high temperature. All right. See, this is good exercise. Good stuff going on there. All right. Now, this next one, I want to go ahead and tell you, anytime you're looking at input, the input is going to be your independent variable. So the function relates to input K to output, and then the output is going to be that entire function. All right. So the output is going to be the M value when you put in the input. So what is the dependent variable in the function? Well, its dependent variable is always going to be rely upon the input or independent variable. So therefore, we have the dependent is M here. So that's how that works. Just think about it. Input would be independent, so K has to be independent. Therefore, by default, then by the dependent has to be M. All right. So this was a good exercise. All right. I hope that you guys are finding this engaging. I mean, it's not too bad. I'm going to speed this up a little bit so we can get through. But Jenna has a part-time job entering data in the computer. Her pay at the end of the week is affected by the amount of data she enters each hour. What is the dependent variable? The dependent variable is going to be the amount of money she makes, right? Because their pay is dependent on how much data she enters. So the dependent variable is the pay at the end of the week. The function related to input M, which is the dependent variable. The dependent variable is going to be N. And then a graph in an atlas shows how a city's average temperature varies in relation to its distance from the equator. Now, in this case, we're not talking about controlling averages of average temperatures. We're looking at relating temperature to the equator. So now the further away from the equator you are, the further or the lower temperature you get, if especially during the wintertime, right? If you're looking at the northern hemisphere right now. But the southern hemisphere is dealing with their summers right now. Okay. So now we're looking at the average. What is the independent variable? The independent variable is the distance from the equator, and the temperature will be controlled by, not controlled, but will be influenced by the distance you are away from that equator. All right. So yeah, well, I said can you control temperature in the other question, it was a different type of problem in relationship to this one. So this is a matter of reading. It really is a matter of reading. You got to understand what you're reading. So now we have input and output. Okay. It says Mary wants to buy a new house, but needs money to put down, down payment. Her parents agreed to lend her money at an annual rate of 5% charged as simple interest. They lend her $3,000 for 4 years. She makes no payments except for one at the end of that time. Answer the following question. So, if that's the case, what we'll do is look at this from a perspective of filling it in. All right, let's see. Now, all we're going to do is go ahead and fill it into these pieces. So we're going to go ahead and do $3,000 plus $3,000, right? Because all we're doing is filling in this and this. And then we're going to go ahead and do the rate being 5%, as indicated by the problem. And then the simple interest is over 4 years. Now, we're looking at using our calculators, remember, grab your calculators for these kind of things. Turn it on and do $3,000 plus $3,000 and then times 5%. So I need my percent key times, and then it's 4 years. So we have now $3,600. I saw some students answer these questions in one of my classes, and I was just baffled how they did not pay attention to anything that I've instructed. Like, you're allowed to use an index card on my test, and it's like the kids did not do well. For those who just, I was just flabbergasted. But anyway, not this class though. All right, what will the total payment amount be, including interest? So now the thing is that I actually answered the second part here by doing this. So the interest by itself is only $600. Just the total interest will be, and then you can get that by just doing this part of the problem, and that is the PRT. All right. So are there any questions on that one? All right. So now, believe me, I give a question like this on the test, and I'm like, it should be really easy, but people just don't understand it. I don't get it. It says right here, right? It says right here that books B. All right, let me do this big. It says that Karma earns $54 per week, and then for part-time, working part-time at a bookstore, she makes $1 more for every book she sells. I really just don't even care about all this reading. I look at the equation that's already been provided to me, and I know that by relationship of the fact that Carmen is working and stuff like that, that A must be the amount, and B is the number of books. So how much does Carmen earn in a week if she sells 23 books? It is literally just taking and adding 23 to $54. That's it. There's nothing else more to this. So 77, and I'm done. Is that ridiculously easy or what? I mean, that goes back to like second grade, doesn't it? I mean, it's like all you gotta do is put in 23 into the equation and solve for it. There's no rocket science to this. There's no, doing a distributed property or doing all kinds of crazy stuff that you do in, intermediate algebra and college algebra, stuff like that. It's just simple replacement. So right here, all we're doing is replacing in the 50 for the x, because watch, it says that x is the given miles. So you can use a calculator to do that. If you can't do it, without a calculator, just go ahead and say, oh, well, 0.06 times 50 plus 9.75. So I get that, and I just put that in there, 1275. This one is the same thing as before, just going ahead and typing it. Well, I think you could do that. 4 times 25 is going to be 100, right? So that one's pretty simple. Think about like, quarters. If you have 4 quarters, it's $1, right? But this is $25. Let me know if you have any questions. I mean, this is about you. I mean, if you don't understand what I'm doing, just let me know. That's the whole point of all this, right? So now this one is a matter of, like I said, just like we would replace all the points here, we're going to replace all those. And we're going to be solving for V, right, when U equals $23, or not $23, but 23, and then plus 8 times 4. So this is 32. 32 added to that is going to give us 55. And that's our answer. I might be going fast, but I don't want you to overthink this. It's absolutely no overthinking. Just plug and chug. There's no real rocket science to it. As long as you can read a letter and see that, oh, A is equal to 8. That's why I put the 8 here. Oh, T is equal to 4. So what does A doing to T? It's multiplying, so that's why I multiplied. See what I'm saying? So just make sure that you're careful with your replacement values, and then you can do the math, the simple math at that. I mean, this is, third grade multiplication and then second grade addition. Just think of it in that way. I mean, because go back to a happy place, because you were happy when math was simple. It's not until you got into algebra when you got frustrated in algebra 2 and geometry and in high school that you got angry. So, I mean, you're allowed to use a calculator, right? So here it's just a matter of multiplying. Well, 30 times 0.1, it's going to be 3, right? And if you don't know that, I mean, it doesn't matter. You can just do 0.1 times 30, and it'll give you 3. You're subtracting that from 1525. So 3 subtracted from 15 is going to give you 12. So the answer is 1225. And you can punch all this in the calculator if you don't feel comfortable with doing it where I just did it. I mean, you can just punch the whole thing in the calculator. I like to personally think a little bit. So I like to go ahead and try to do it mentally if I can. I'm not saying I can do that type of problem. Melanie, you liking this so far? Is this pretty good for you? Just lie to me if you have to. I mean, just say, yeah, Mr. D, I love it. It's the best thing since sliced bread. All right, well, good. I'm glad you think it's pretty simple, because it is. Just keep it simple, right? Now, I guess, Maria, you guys all doing okay? I mean, you guys are pretty quiet, so if you need me, I mean, I'm here. Just speak up. All right, now, you got negative 5, right? Because you take the opposite of x, and then you're doing 7 times negative 7, right? So that's the simple replacement. So this is going to be negative 49, and then you have negative 5. So here we're going to go ahead, since they're both negative. Some students freak out when they see 5 minus 49. They just automatically subtract, and they make all kinds of goofy mistakes with this. So if that's your problem, maybe it is, just take your calculator and do negative 5 minus 49. And then that would be what you have there. This looks similar to what we have there. So your answer would be negative 54. Now, this is all about input and output. So what you do is you create a table by just simply putting into the equation. Now, I can do it mentally, but I'm not going to do that to you. You can go ahead and do this. This is what you do. Negative 2 times negative 5 is going to give you positive 10. Positive 10 plus 2 is 12. So that's the first answer we're going to put in there. So 12. Now, the next one, you put in 0. So y equals negative 5 times 0 plus 2. This is going to give us 0. So then you go ahead and say 0 plus 2 is 2. And I'll put that in there too. And you get the idea. So we continue that. All right. So a lot of these, in the next problems I'm going to do, I'm going to probably do them mentally because I could do all these mentally. And why is that? It's because, yes, I understand. I'm a teacher, whatever. Who cares about that? The fact that I'm doing is I can retain numbers in my head. Like I know -5 times 2 is -10, and -10 plus 2 is -8. So I'm done. There's my answer, right? I could have done that without writing anything down. So -8. Now I'm going to do the same concept, this time with -5 times 4 plus 2. This is going to be -20 plus 2, which is going to give us -18. All right, and that's correct. So the concept is just input and output. All right, I'll do that one more time, this time with doing it mentally. -1 times -10 is going to be +10 plus 2 is 12. 0 times 10, -10 is going to give us 0 plus 2 is 2. 1 times -10 is going to give us -10 plus 2 is -8. And then 5 times 10 is -50. -50 plus 2 is -48. See, I mean, again, I can do that mentally without having to write all this business down. Like, this was a lot of work to write it all down, right? I mean, if that's how you have to process it in your mind, then by all means, do it. But it's just, you can do it mentally if you can. All right. I'll let you guys have this. I mean, because that's like -12 times, or it's going to be +12 plus 3 is, 15, I mean, so on and so forth. You guys could do that now. All right. Again, same thing. 1 times 2 is 2 plus 1 is 3. 3 times 2 is 6. 6 plus 1 is 7. And you guys can do that. And it looks like they keep on giving us the same things here, just repeating itself. If you need me to do more, just let me know, of course. All right, now here it says, there are C balloons at the beginning of the party. By the end of the party, 4 of them have popped. Using C, write an expression for the number of balloons that were left. Well, obviously, balloons being popped means that it's being subtracted, right? So the thing is that I have to get C, because it's some number of balloons for the C, all right, minus the balloons that pop. And then that would be the expression that we need. All right, pretty self-explanatory. I mean, you can figure that out just by reading. All right, well, then that concludes this lesson. Are there any questions? Well, again, thank you for putting up with the fact that my audio was all goofy. I'm going to stop this recording